Okay, guys, so welcome to this webinar. We're delighted to be able to do our first webinar. Now, this one's going to be the start of a series of webinars. We're going to look at digital twins this time. We've actually been building digital twins for about, well, data models for the past 10 years. And now the topic's become really popular, which is fantastic. What I'd like to do today is talk about, just very briefly, what a digital twin is and isn't from our perspective. We're not going to go into a big history of it. And also then I want to talk about a key aspect of every digital twin, which is a data model. I then want to take one aspect of this and focus on it really for the purpose of the webinar, and that is the concept of intelligent objects. And then we're going to spend most of the webinar looking at a demo of that, and then there's a chance for some questions at the end. So quickly then, our background in digital twins and what are we going to talk about today? We've been building data models for the past 11 years now. Our view is that a digital twin is actually made up of many systems. It's not one application. There's an analogy you can take with the idea of an airport, which everyone understands what the concept of an airport is, but it has many different aspects to it and people interact with it differently. So for example, you have planes will arrive and leave, that's interfaces to it. Customers will come in one entrance, have a check-in desk, they'll put their bags, will go through something, so you've got check-in systems, baggage systems. Then there's an interface with a global standard, which is like air traffic control. So there's certain understood handoffs of information between systems, but also every single airport is different. So you might have a London airport, JFK, Paris. They're all different airports, but conceptually we understand what they are, what we'd expect the functions to have. We had a great conversation with Dave Hodgson and Andrew DeLuga on what is a digital twin, and I've put a link in the slide. I'll actually share that in the chat later if you want to have a look at that. But there's a series of, I think, 11 videos where we, just short ones, 5 minutes, what we discuss of what our view is. But for the purpose of this video, I want to just share why I think it's going to be useful in the future. And that's because a digital twin is going to be your way into your data, your information, and it's also going to be a record of the journey of that information through the life of the asset. So it will actually start in the project and go through operations and end in decommissioning. Okay, so what's an important feature of a data model that we believe, and that is, sorry, of a digital twin, and that's the data model. This is like the map that describes how your information is connected. The information may sit in many different systems, but you need a way to understand how it's related and how to navigate it. From that, in the model, you have objects. And the concept I want to focus on today is this idea of intelligent objects. An intelligent object carries the information with it on its journey. So it's not just, let's say, the example we're going to look at is a test separator. It's not just the name of that separator. The object needs to carry with it all the information about what it's related to, things like documents, time series objects, any maintenance that's going on with it. So the demo that I'm going to show you now, to give you an idea of how it might actually look, how does it look to work with this, I'll just show you what it would look like if you had to interface with the raw model itself. In our data models, we use Neo4j. So what does the output of that look like? But then we'll see how it looks in a UI for a user. And then I'll show you simple examples of how we can reveal that information and then how a user might actually use it. This is what it would look like if you just queried the data model directly using a tool called, in this case, Bolt. It will return you everything much like a SQL tool, and you can navigate it. If you're an admin, that might be a good way of getting into stuff, but as a user, it's really not so useful. So let's take a look at the example. What we're going to do is we're going to search for a piece of equipment called a test separator in our demo system, which is we just have a simple data model of an offshore platform. I'm going to drag that object into a text editor to show you all the hidden data that's behind it. And then we're going to see how that looks, how that drives certain features that users can interact with in the front end. So to do that, I'm going to just stop my screen share here. And then I need to share another screen. Stop share, screen share. Come on, the desktop. Okay. So here you have our demo simulation. It's just a simple offshore platform with a small data model behind it. I've already searched for it once. Let's just clear the search. The search would be a standard way into, say, a data model or a digital twin. We're going to search for test separator in this case, and here's our object that comes up in the results. If I click on that object, it brings up a thing called common menu, and that shows you, like in a formatted way, all the related information that we know about it. So we've got its properties that might come from a master equipment system, any measurements that you have that might be time series, if there's any alerts active on it, or documents, or if there's related assets in the model, or if you had any maintenance on it. All that information stays with that object when you drag it around. So if I take this object and just drag it into a text editor, it kind of reveals everything that's going with it. And I'll zoom in on this in a second, some slides to make it easy to understand. But to give you an example of what that means, I'll just clear my basket. You can grab that object and then work with it. So here I can put it in a thing we call the shopping basket, but it's a way of collecting objects that you want to work with. And then if I was to put a visual display component, this is called a sunburst, I can drag and drop this object onto it. And this sunburst object knows then to follow certain relationships by default. If I go in, then I could maybe color it by if anything has a particular status, or if there's any active alerts. This component's then pulling out the relevant info from this object. So let's now go into a little bit more depth on this object here. We're going to look at one of the related objects, which is a time series object. So I'll open up the common menu and I'll go to the measurements tab. And here we've linked time series data in it. Now, this value here also happens to have a limit against it, and it's picked that up. So if I show you, just like I showed you with the actual object itself, I can drag this object into my text editor and it reveals all the context from the model about that time series object, including the source for its data. So this data is not stored in the data model. This is stored in another system. So all we get is the pointer to that object. But as a user, I haven't had to go into that other system. The data model is just going to go fetch that for me, or the interface is going to go fetch it. And then, so if I click on it to make a trend, it says, oh, and it doesn't now demo it. Let's go back and I'll clear my basket of everything and show you, you can drag time series objects into your basket, and then from there you can make a trend of them or not. In this case, tell you what I'll do. I'll open a blank trend. Oh, didn't mean to actually trend that. Just open a blank one. The object's draggable onto the trend. Genius, the curse of a webinar. That would have trended normally, and what you'd also have seen is what would come with it is there was an alert on that tag. You can see this is status green, so it hadn't breached it. But there was the green status. If it was red, it would have colored it red. But that alert is actually a marker, and that's draggable as well onto it. So let's go back just to the slides, because I want to pull out some of the aspects that were in that text of related information. So I just go back to my, actually, guys, was I screen sharing at that time? Let's see. I just want to check. Was I? Could someone please put in the chat if you could see that demo on the screen? Yes. Okay. That's a relief. Thank you. Because I just saw here that the pause screen sharing was on. So I'll just share this presentation again. Go back into presentation mode. Okay. So there's a couple of points in the that I wanted to pull out of that text that you saw. One is the asset class. That was in every object in the model needs to have a class or more than one class, because as humans, it's very easy for us to talk about things in general. I talked about an airport. That's a class. You can have an aeroplane, a car. These are all actually general classes of thing. There is no general airport in the world. There's only specific instances. So when you interact with objects, it's very important to be able to know what they actually are. And that can include the general class as well as the very specific class of object. So you see an intelligent object will carry with it its class. That's essential for any intelligent or any app that's going to interact with it. The other thing that I wanted to describe was documents. This is an example of related information that exists in another system. And so here we have a pointer, and you can see that there's a URL. And again, in this case, it's our demo system, but it has linked to that object. It's got a description of a document, and it's got where it's actually stored. So if that was a document management system, you'd know, then you'd always get the latest version of that. So in the data model, we're not trying to replicate information that's stored in a very good way in another place. Okay, and there was the example of the trend, which a screenshot I took earlier before obviously it stopped working. But this was an example of just enumerating that information stored in another system. Okay, that is just about perfect timing. So any questions? So I need to get my panel thing back up here, and I can look at questions from the panel. Okay, Q&A, here we go. Okay, has anyone got any questions that they'd like to ask based on what you've seen? So for example, I guess one question might be, where does the data come from for the data model? And to answer that, I would say it can come from all kinds of different places, and you can start really, really small. You could start with, like we had, just a simple model, and it might come from your master equipment data. But the beauty of a data model is you can add to it over time. It's not a fixed structure. And the beauty of something like a graph is that you can add to it over time. You don't have to sort the schema from day one. I've got a question here from Edmund. Thank you, Edmund. So are you using any international standards for the data model? Great question. Yeah, we try to, very much so. So where possible, we have our own internal class library, and we've based that on CIFOS, which is an international standard. In reality, what you find is different assets have used different class libraries, if one at all. So some legacy assets may not actually have been built against the class library. There's some standards like NORSOC, which are very similar to CIFOS, and also ISO 15926 as a class library. Our dream would be to build up a common standard. I think in reality, what you end up doing is having to tailor the class library a little bit for every single asset. What you can do though is to have objects with multiple classes. So you can actually map new classes to an object later in its life cycle. So if you start off and it's called, let's say, a pump, in the future, if you find that the international standard has called it a fluid moving device, then you could add that class to the object without removing the other one. And this is a beauty of having something like a graph that you can just grow over time. So you can have the concept of multiple inheritance for something. I think this is a great way, or it's almost like a roadmap for moving people from where they are to actually using international standards, because it gives you a path where you can start with what you've got and keep working and then evolve it towards something that's common in the future. Question here from Effie: how does Eigen technology compare with 3D model digital twins? So I would say the 3D model is one of the systems that you would have in a digital twin. It's one particular view. It has masses of information. The 3D model is a very good visual representation of stuff, and it gives you like a visual query language as well, because if you can use it to visually show where equipment has a problem or where it has work active, that's a fantastic view on it. It doesn't store how that information in the model is related to non-physical stuff. So for example, the concept of a safety barrier or protective function. The rationale behind it is the prevention of a major accident. It's not a physical thing that you can represent, but it's a concept that we can understand as humans and we talk about. And actually a lot of the reasoning for stuff is hard to visualize, and it's certainly not physical, but it can be represented digitally. It's called an abstract object. And actually a digital system doesn't care whether it's physical or not. So the data model we've described could have an interface to a 3D model, and it could be a source of providing additional information that's not in the 3D model. So it could definitely enrich it. It can also have links to objects in the 3D model. So let's go back to our example of that pump. A pump will have a physical version of that pump on the platform, but you'll also then have a reference to an international standard. You'll have maintenance on that pump, and it may be there for a safety reason. You'll have a link to that, the reason it's there. So where does the concept of the pump exist? Well, it's not just in a 3D model. Actually, a 3D model just shows you the instance of the pump on the platform. The data model stores all the other stuff as well. I hope that's answered the question. Any other questions from folks? I think I'd be interested in any, if anyone has any comments on where they've seen digital twins in action, or people's experience with them, or maybe thoughts on where they think it might be going. Paul, I see you've raised a hand. Would you like, did you want to share something? Or not? I think sometimes, okay, thank you. Question here from Christoph. What strategy do you use for integrating the solution, the digital twin, or our technology into a client's environment? The key is to start small and to go step by step. Making integrated systems is complicated, and what you find early on is that there's a lot of cleanup needs to be done on the information. So coming up with a comprehensive data model is really, really important to doing this well. And there is a dream, I guess, that this could be automated, and one could point a magic script and just have something go sort your data out for you. That's quite difficult in reality. We may get there at some point, and that would be something like assisted learning. What you'd have to have is a machine learning system watching a human and learning how human mapped and linked and cleansed the data to build the model. So how does one go about it? Well, you start small, you get the master equipment data, you understand the class library, and you start building links. A lot of it can be scripted. So while I say there's no magic script that can do it all, humans can write script fairly quickly. Engineering numbering specifications are a great way in to understanding how to identify related things based on number patterns. Paul, so you've got a question here on, okay, yeah, oh, it's a comment, sorry. With this system, you can read data from lots of sources and bring it together. Yep, that's definitely true, definitely true. That's the beauty of actually having a data model, is the information can be in different systems. You might have multiple different sources of time series data, but from the user's perspective, then they don't care. It's easy for them to interact with it and start doing something valuable rather than searching for the information. Okay, guys, any more questions? Okay, well, I think that's great. We managed to keep to time. I hope you found that useful. Oh, sorry, there's one coming in. How long does it take to implement a digital twin on such an offshore platform? And how, okay, there's two questions. How do you continuously stream live data into your machine learning models in the cloud and a digital twin from the offshore platform? Is everything run on board? Do you use compression algorithm to clean the noise out of time series data prior to stream through VSAT? Do you use edge computing? Okay, right, so there's multiple questions there. I'll take the first one. How long does it take to implement such a digital twin? So our demo system's a super simple example, and you could probably implement something like that in a week. If you want to layer more complicated information and say add safety barriers in, which generally involves understanding some philosophies and strategies and documents, that takes longer. So the short answer is you could implement something based on existing well-structured data within a few months, probably. To implement something that's very comprehensive, includes abstract concepts like barriers, is fully verified with stuff, then you're probably looking like from 6 months on. There's also an aspect around continual improvement of that model. So being able to say when the model is done, you're probably always going to be working on it in some form. But if the question is, how long does it take to get it usable? Actually, you can get it into a usable state very quickly. So then to the question of how do you continuously stream live data? So machine learning models, one of the very important things you don't want to do is run machine learning models off your live production systems. The reason is machine learning is a massive consumer of data. It's like attaching a fire hose to a kitchen tap in a way. What you need is something that can provide data at a very high rate on demand, and you won't see a performance hit. If you did that against an existing Pi or IP21 or PhD, you'd very likely pull it down. So actually, if you're looking to do machine learning, what you should be doing is actually duplicating that data into a side system that is specifically for training machine learning models, AI models. How do you stream it? Okay, stream into the cloud. So again, I would say that is putting it into a separate system that's maybe in the cloud and run your machine learning models from there. Is everything run on board? So just running something like I've just shown you is fairly lightweight, and you can run that. You could run it offshore if you wanted. You can run it on-prem, or you can run it in the cloud. Our software is cloud-based, so when we say on-prem, all we do is set up a local cloud. In this instance, so it doesn't really matter too much, I suppose, where you run it. If you have problems with slow bandwidth between your site and the cloud, then it would make more sense to run it at the site. do we use compression to clean the noise out of time series data? So cleaning of data is typically done as near to source as possible. We don't have machine learning models. So what we're not doing as part of the data model is having lots of ML and AI. You're absolutely right, though, that it's important to clean it before you do any such thing, because of junk in, junk out. So typically, cleaning of data would be done in, for example, the historian. You might have compression configured there. You might have dead banding, stuff like that. You can also do it at the edge. As you say, you may have smart devices. I know companies like, for example, Siemens and Emerson are pushing more edge computing devices that can handle much higher scan rates and also do some pre-processing of the data before they send it on. I think that's a really interesting development and it makes a lot of sense to do it. And in many ways, running trained models at the edge is probably the way to do it, where you can have as high frequency data as possible. Okay. Okay. So, okay. When is the right time to say an asset digital twin model is complete, connecting to all systems required, or question mark? Okay, great question to end on there. I think I've got 2 minutes. So the reality is probably a bit like a human being. It's never quite complete. I think a digital twin will continue to grow, but also just like a human, it becomes useful fairly early on, and once it's even learned the basic, it can start doing things like, for example, children can help with the washing up when they're quite young. So I think that it's important to define a small project initially to get going, because there's a lot of learning done in an organization around data quality, how you use the data. So the question came up on class libraries. Just discovering the quality of the information structure relative to a class library early on can be very revealing. And you need to understand if you have a lot of cleanup work to do or if you can keep going. The other thing to say is to have use case milestones. Actually, if you start building your data model with specific use cases in mind, then you give yourself intermediate milestones where you say, actually, this bit is complete and it's delivering value. But the great thing is people will start then firing ideas when they see what's possible, and new ideas will come up continuously with new cool stuff to add to your digital twin. So okay, we're basically out of time there, but I hope you've enjoyed it and found it useful, and look forward to hearing more from you and to doing the next ones in the series. Thanks very much, guys.